Predicting optimal dietary habits for fast recovery from COVID-19 using machine learning techniques. Abstract. 1. Background. COVID-19 is a life-threatening disease which has affected a lot of people all over the world. This disease becomes deadlier if not taken care of properly by healthy diet and enough rest. 2. Objective. This paper focuses on finding the most important food items that help in recovery from COVID-19. 3. Method. This was done by calculating effects of intake of different category of food items. After calculating the recovery rate from the dataset, each country was divided into categories depending on their recovery rate, which made it easier to observe the food intake habits. Boruta algorithm was applied to find out the most important factors contributing to recovery of a person. Multivariate analysis was carried out to compare different food items to recovery rate. Results. The research concluded that percentage of protein taken from vegetable oils, percentage of fat from cereals except beer, and percentage of kcal from cereals, meat, and milk were the most important factors in recovery of a COVID-19 infected person. Keywords: COVID-19, dietary habits, recovery rate, protein, fat, kcal, Boruta algorithm, multivariate analysis. Introduction. At the time of writing this article, COVID-19 had already taken over the world, affecting millions of people all over the world. Currently there are 171,244,796 total cases, with 154,526,625 people recovered. Many countries are going through second wave of COVID-19, and some countries have already faced the second wave. People have been living isolated in their homes for the past 1 year. Wearing masks was used to prevent catching the virus through air. Sanitizers were used to avoid getting it through touch. Nobody had imagined that such a pandemic could occur and disrupt lives like that. Offices, universities, shops, factories, etc. all closed to prevent spread of the virus. Even though everything is reverting back to normal now, the process is slow and the virus has evolved in the past, so it's possible that it changes again. COVID-19 has made a devastating impact on the economy as well as healthcare of some countries, especially developing countries. In such times, all countries have come together in unity and supported each other whenever there is need. Vaccines have been invented, but they are not completely effective and their production is slow, especially for developing countries with vast population. In such times, people were recommended to maintain a healthy lifestyle, like doing yoga, exercise, eat healthy food, etc. The positive thing that came from COVID-19 was people came together, they donated blood, plasma, etc. whenever need be. And it showed how countries adapted to the situation and allotted more resources for vaccine researching companies and opened hospitals specially for the virus victims, and medical workers all around the world worked day and night to save everyone possible. Being a victim myself, I realized that diet played an extremely important role in my recovery. There is great awareness everywhere that eat healthy for fast recovery, and this study tells exactly what category of food items will help in that. Materials and methods. Dataset. This study used the COVID-19 Healthy Diet Dataset 7 to find what category of food items lead to most possible recovery rate of a COVID-19 infected person, also to study different patterns of diet consumed by various countries. The COVID-19 Healthy Diet Dataset has information related to 170 different countries and their percentage intake of nutrients from different type of food categories like alcohol, animal products, aquatic products, cereals, eggs, seafood, fruits, meat, miscellaneous, milk, offal, oil crops, pulses, spices, starchy roots, stimulants, sugar crops, sugar and sweeteners, tree nuts, vegetal products, vegetable oils, and vegetables. 1. This research used 3 CSV files to study the 3 main nutrients of food, namely protein, fat, carbohydrate. Percentages of protein consumed from each type of food item given. Percentages of fat consumed from each type of food given. Percentages of energy, in kilocalories, consumed from each type of food given. Data pre-processing. As mentioned in the above section, the dataset had 170 countries, but it was reduced to 169 countries since French Polynesia had almost all values missing. The undernourished column had operators which were removed and replaced with the suitable values. All missing values of the column obesity were filled with the mean of all values in that column. DRANA was used before training the model or implementing the algorithm. To implement the Boruta algorithm, recovery rate percentage was needed, which was calculated using formulae. Number of people having COVID equals percentage of people having COVID asterisk population of each country. Number of people recovered equals percentage of people recovered asterisk population of each country. Recovery rate equals number of people recovered / number of people having COVID. Recovery rate percentage equals recovery rate asterisk 100. The recovery rate percentage column was inserted at the end of all columns. To train model using random forest classifier, category was created that categorized all countries from A to F. A having the highest recovery rate. Methods. Maria et al. Conducted a study which said it was observed that countries with a high degree of obese people and with a higher average daily caloric intake are related to a higher risk of death from COVID-19, while countries with a high number of undernourished people do not show an increase in these percentages. The above-mentioned study is focused on mortality rates and deaths. In comparison to that study, this research is based on recovery rate and finding what category of food items play the most important role in a person's recovery. In this study, random forest classifier is used by keeping category column as Y, predicted value, and rest of the columns as X. While Boruta algorithm uses recovery rate percentage as Y, predicted value, and rest as X, which will return a list with each column weight. This algorithm uses random forest regression. Given below is a brief explanation of the two used methods. Random forest. A random forest is made up of a huge number of individual trees that work together as a unit. Each tree produces a class prediction, with the class with the highest votes becoming the final output too. Because it reduces the variance of the model without increasing the bias, this bootstrapping approach improves model performance. As long as the trees are not correlated, this means that while a single tree's predictions are highly sensitive to noise in its training set, the average of several trees is not. Simply training multiple trees on a single training set would result in extremely correlated trees, or, if the training technique is deterministic, the same tree multiple times. Bootstrap sampling is a method of decorrelating the trees by exposing them to different training sets. 3. The approach described here is the original tree bagging algorithm. Random forests differ from this basic scheme in only one way: they employ a modified tree learning algorithm that selects a random subset of features at each candidate split during the learning process. This process is sometimes called feature bagging. The reason for doing this is the correlation of the trees in an ordinary bootstrap sample. If one or a few features are very strong predictors for the response variable, target output, these features will be selected in many of the B trees, causing them to become correlated. An analysis of how bagging and random subspace projection contribute to accuracy gains under different conditions is given by Ho 4. Boruta algorithm is a feature extraction algorithm. It was first introduced in R language 5. Instead of competing against themselves, features in Boruta compete against a stochastic version of themselves 5. In practice, a new data frame is constructed by randomly shuffling each attribute starting with X. Shadow features are these permuted features. The shadow data frame is now joined to the original data frame, yielding a new data frame, named X_Boruta, with double the number of columns as X5. Now we compare the relevance of each of the original attributes to a threshold. This time, the threshold is defined as the shadow feature with the highest feature relevance. This is referred to as a hit when the relevance of a characteristic exceeds this threshold. The premise is that a feature is only helpful if it can outperform the best randomized feature 5. In random forest, the z-score is computed by dividing the average accuracy loss by its standard deviation. It is used as the importance measure for all the variables. But we cannot use z-score, which is calculated in random forest, as a measure for finding variable importance, as the z-score is not directly related to the statistical significance of the variable importance. To work around this problem, Boruta package runs random forest on both original and random attributes and compute the importance of all variables. Since the whole process is dependent on permuted copies, we repeat random permutation procedure to get statistically robust results. 6. There is one disadvantage of Boruta algorithm, and that is it takes too long to execute. Suppose the dataset is large and number of iterations are more, it may take hours to execute. Increasing the iterations will show more weight in the output to make it clearer, but the result remains the same. Multivariate analysis. After applying the algorithm and training the model, multivariate analysis was performed by plotting scatter graphs to check if all graphs are similar for the output given by Boruta algorithm. Furthermore, it was found out that from the dataset that Nepal and Djibouti had the highest recovery rates, 98.53 and 98.50 respectively. Results and discussions. In this work, a study was carried out on the recovery rate of people in a country. First, the dataset was cleaned and recovery rate percentage was found out for each country using the confirmed, recovered and population columns. Using simple Python coding, a new column was made that categorized all countries from A to F, A denoting recovery rate from 95 to 100, depending on their recovery rate percentage. Using train tests, split the columns were divided into train data and test data, with category column as the output / predicted or Y column, while rest columns as input or X. Random forest classifier was implemented and an accuracy of 0.75 or 75% was achieved, for the protein CSV file. For other CSV files the accuracy was in close proximity. As mentioned in the methods section, just having a score is not enough. To find out the most important features, Boruta algorithm was applied and it was found that percentage of protein from vegetable oils, percentage of fat from cereals except beer, and percentage of carbohydrates from cereals, milk, and meat were the most important features for recovery from COVID-19. In the methods section, information about random forest classifier as well as regression is given, since first code used the random forest classifier and the Boruta algorithm used random forest regression model. Finally, to confirm the results, scatter plots were formed and all above mentioned features had a similar pattern. In future work, a more detailed study can be done by analyzing the dietary patterns of the countries with the highest recovery rates and compare that patterns with low recovery rate countries to know what food to have and what not to have. Funding. This research received no external funding. Conflicts of interest. The authors declare no conflict of interest. Experimental subjects / animals. No subjects or animals were used in the study.